Hello, my friends of Hatari Labs. My name is Oro Montoya. Please welcome to this tutorial. In this tutorial, we are going to use a Python class that we have developed in order to generate the geometry from Modflow 6 models. Okay, so there are some tools in Flopy that address the generation of VTKs. Okay, we have used those tools besides another ones, and then we have created a Python class that is a bunch that is a compilation of code that helps you to export the geometry in few times and with great results. Okay, so let's start. So on the description of the video, you are going to find the zipped folder, and here you are going to find an example model, the executables, and the scripts, and the folder where the VTKs will be stored. So we can delete this because this will be generated by the class. So let's start. Please place this folder under your document folder, and let's type anaconda prompt cd documents cd python class, and then here with the Jupyter Lab, and then we wait. Great. Okay, so let's go here to scripts, and let's go here to VTK class. Okay, the Python class is here in working tools, so but you actually call it from VTK. Okay, so restart and clear all outputs. First, we define the simulation. First we import the Python class, then we find some paths, the simulation name, the where the simulation is located, the executable, and where the VTKs will be stored. Okay, and then we call the Python class with all the parameters, the simulation, the folder, the executable, and the VTK. Okay, then we load the simulation. Okay, we load the simulation, and this method actually deletes everything that is on the VTK, because each time that you run, you can, I mean, if it doesn't delete those, I mean, for every time that you run, you will be creating multiple BTKs of the same thing. Okay, then so, and in Modflow 6, you have the simulation and the model. So, and the load simulation will give you which all the models that are inside the simulation. Okay, most probably you are going to have one model besides one simulation. Okay, and here you have to load the model by its name. Okay, because this is the name of the model on the simulation. You load the model. Okay, and then you create some arrays. I mean, you create a VTK of just the geometry. Okay, and then you create some parameters. No, you just create some VTK of just the geometry without any other value. Okay. Okay. And then we create the parameter VTK. And okay, so let's create the parameter VTK. In this parameter VTK, it exports some values that we are going to see. Okay, and it also creates some numpy values. Okay, because somehow we attach to the geometry the different values and the different value for each cell, and these value for each cell are stored as a numpy files. Okay, and then we create the boundary condition and observation. Okay, this Python class so far only works with the boundary, I mean the parameters, the boundary conditions, and the observations. Okay, in the future we are going to provide the simulation of the Python class, and as well the export of the heads and the curtain lines. Okay, so this was the first time that I have used a decorator. So for every boundary condition, we see how much it took it for to do it. Okay, in the case of the recharge, it's much less, and this is not because you will see that these are smaller files, but the process here is much more stepwise, okay, than this one, okay, because in this one, well, this is some issues that I had with PyVista, and and well, there are some issues with PyVista that, and this is and this subsequently this is this creates that for the charge is much faster than for the GHB. Okay, so what we have in BTK, we have a BTK for the drainage, a BTK for the general head, a BTK for the recharge, and BTK for the observations. Besides, we have here the all the parameters that the Python class has found. Okay, the easel type, iDomain, and the key and the starting heads. And as well, we have the geometry and the parameters. So we go here to ParaView. Okay, we go to my documents, to the Python class, to the VTK, and then we open the parameters. And for example, we can plot the K, and then we can give some. The model is kind of flat, so we can increase that. Okay, so these are the K values. Okay, great. So I can do a clip on the. Okay, let's invert that. And then we always have to give. Okay, great. For example, and then let's plot the key. We can open the drainage. Okay, these are the drainage. Let's give the. And the drainage also already comes with the elevation and the conductance. Okay, and then we have the general head. These are the general head. Also, we have to give them. Okay. And then what else do we have? We have also the observation files. The observation files with the scale. And the recharge as well. And these are the recharge with the scale as well. Okay, as we see, we have here, well, all these boundary conditions and all of these parameters that are generated if we go are generated with just 8 steps of the Python class. So it's actually pretty fast and pretty simple. Okay, so that is, I strongly recommend that you follow the tutorial with the model provided, and then you can try with your own data. And that's it so far. My name is Saul Montoya. Thank you for following this tutorial. If you want to support our project, I strongly recommend that you sign. And then if you like Flopy, you sign for the coming diploma in Flopy that it will be from March to July of 2024. And this will be maybe one of the few opportunities where we are going to have live classes with live support, and in Flowpy where we are going to discuss, share, and then you can put your own, then you can get answers to the questions in real time. Okay, so just visit shop.hatterilabs.com and hope to see you in coming tutorials.